Okay, here's number 50. Oh, this is 57 in your packet. It's 4NH3 plus 7O2 yields 4NO2 plus 6H2O. And the question is asking how many grams of nitrogen monoxide and water. So we have to find actually the amount of both products can be made from 100 grams of NH3 and 100 grams of O2. So first thing I got to do, I got to figure out which one is my limiting reactant. 100.0 grams of NH3, that has the chemical name ammonia. 1 mole of NH3 has a molar mass of 17.034 grams. And when I put that in my calculator, I get 5.8706. That's how many moles of ammonia, right, I start with. How many moles of oxygen do I start with? Well, if I have 100 grams of oxygen, I know that 1 mole of oxygen has a molar mass of 32.00 grams, and so I will start with 3.125 moles of oxygen, right? This is how much I have. This is reactant 2 that I have. So that was step 1. And then step 2 is convert reactant 1 to reactant 2, right? And so I'm just saying how many moles of oxygen do I need to use up all my ammonia? So ammonia, I have 5.8706 moles of ammonia. And according to the balanced chemical equation, 4 moles of ammonia will take 7 moles of oxygen to use up. I put that in my calculator. That tells me 10.27 moles of oxygen needed to use up all my ammonia, right? And then the third question is all about comparing need versus have, right? Do I have enough oxygen to use up all my ammonia? Well, in this case, it looks like I only have 3.125 moles of oxygen. So I don't have the amount that I need, right? So the have is less than need, which means I can't use up all of my ammonia. Oxygen is my limiting reactant, right? So O2 is my limiting reactant. And then I have to actually, answer the question. Once I figure out that oxygen is my limiting reactant, right, I got to actually read the question again and figure out what I need to find. I need to find grams of both of the products. Okay, so I take my amount of limiting reactant, which is my oxygen. I can, just take the number of moles, 3.125 moles of oxygen. According to the balanced chemical equation, 7 moles of oxygen will make 4 moles of NO2, nitrogen dioxide, and 1 mole of nitrogen dioxide will have a mass of 46.01 grams. So I will be able to make 82.1607 grams of NO2. And then significant figures, I have 3 significant figures in 100.0, both of them. So I'm just going to round this to 82.2 grams of nitrogen dioxide. And then the other question, or the other part, is how many grams of water. So again, I start with the 3.125 moles of oxygen because now that I know it's my limiting reactant, that's what's going to control the reaction. When that runs out, it stops, right? 7 moles of oxygen will make 6 moles of water. And 1 mole of water has a molar mass of 18.016 grams. So that means I will be able to make 48.257 moles of water, not moles, excuse me, grams of water, and then round that to three significant figures, 48.3 grams of water. Right, so I just answered the question. First step converted both to moles. Second step found that I would need 10 moles of oxygen to use up all my ammonia. I only had 3, so oxygen will run out first. That's my limiting reactant. And then I chose my limiting reactant to answer the question. Right? What is the sentence that I'm going to write here? Right? The first thing we say is our limiting reactant. 100 grams of oxygen is the limiting reactant. Right? And then I think about, how did I logically come to that conclusion? Well, in order to use up all the ammonia, NH3, 10.27 moles of oxygen are needed. Right? I only have 3.1 moles of oxygen. Thus, it will run out first, and oxygen is the limiting reactant. And then our last part of this, how much of the excess reactant was left over, right? We said oxygen was our limiting reactant, so ammonia must be my excess reactant, okay? How much of that excess reactant did I start with? I started with 100 grams of ammonia. How much did I use? I don't know. I have to figure that out, right? Starting with my 3.125 moles of oxygen, right? Because I always go back to my limiting reactant. This is saying that 7 moles of oxygen will require 4 moles of NH3. And I know the molar mass, 1 mole of NH3 is 17.034 grams. So what does that give us? 30.417 grams of NH3 will be used. Right, remember these two must be of the same compound, right? When we're subtracting, we have to always subtract both the same unit and the same compound. Now, before I get my answer, I want to think about significant figures and decimal places, right? This started from 100 decimal point grams of oxygen. So this guy would be 3 significant figures, which would mean 1 decimal place. 100 with a decimal point there has 0 decimal places. Subtracting a number that has 1 decimal place, I should just keep 0 decimal places. So do the subtraction without doing any rounding. I would get 69.581 grams, and then 0 decimal places would be 70 grams of ammonia left over. I start with 100 grams, I use about 30, I have 70 grams left over. I started, right, if I go back to think about what did this problem, I started with 100 grams of ammonia and 100 grams of oxygen. And now at the end, how many grams of oxygen do I have? I have about, I have no grams of oxygen left, because if that's the limiting reactant, right, if that's the limiting reactant, then I would have none of it left over. If I think about what did I start this problem with, right? I started this problem with 100 grams of oxygen and 100 grams of NH3. So I started this reaction with 200 grams of material, right? 200 grams of matter. And then at the end, what did I have at the end? Well, I had about 70 grams of NH3 left over, and I made 82.2 grams of nitrogen dioxide, and I made about 48.3 grams of water. And if I add those up, I mean, accounting for some rounding issues here and there, yeah, I have about 200 grams at the end, because remember, I have no oxygen at the end. And that shows us the conservation of matter, that I started with 200 grams of matter and I ended with 200 grams of matter. I have the same number of atoms at the beginning as the end. It's just, where are they? Okay. If you feel confident, you can move on to the next question, right? The next question is number 58. Or you can go through that problem with me.